All right, so can everyone hear me fine? All right, so as Kevin mentioned, I teach astronomy and physics at the University of Redlands in Southern California. Where my university is right on the outskirts of LA, the Los Angeles sprawl. So when I have my astronomy class, I imagine there's a few astronomy students in here. When I'd have my astronomy class and I would take them outside and we'd look up at the sky, we could count all 12 stars. When I'd ask my students if they had ever seen the Milky Way, I'd get about 2 hands would go up. Let me ask here, how many folks have seen the Milky Way? All right, now keep your hands up. How many of you have seen it from where you live? Okay, you folks are in the minority. Estimates are that currently 60% of the US population does not live someplace where they can see the Milky Way from their home. Worldwide, estimates are, given the demographics of where people are living, 50% of those people born this year will never see the Milky Way. And this is a problem. And it's something, but it's a problem that has grown very slowly. And it's something that I've seen amongst my students. And I've been, the consternation. I'm trying to share my love, my joy of astronomy with my students. And they have absolutely no direct, physical, hands-on, eyes-on experience with anything I'm talking about. Can't even point out a constellation. And this is something that is becoming more and more widespread. And the folks in the national parks are aware of this. Now, just to tell you a little bit about my background. I did my graduate work at Cornell. For my PhD, looking at dark matter in binary galaxies, I went out and did my observations at what at the time was the largest fully operational optical telescope in the world, the Palomar 200-inch telescope, between these two tiny little hamlets of LA and San Diego. And I first did my observations back there in 1992. And I remember going up, standing there at the telescope, going out onto the catwalk outside, looking around and seeing the glow of San Diego off to the south, the glow of Los Angeles off to the north, and a few houses, maybe a little bit of Palm Springs in the very, very far distance, and a few little houses out there in the intermediate darkness. Back in 2005, a friend of mine from Cornell invited me to come back observing with him. That's, in fact, where I took this photograph. We were looking at Uranus that happened to be right next to a full moon, and so that's moonlight that's shining in to illuminate the inside of the dome. And as I was up there, we took a moment and went out onto the catwalk, and what I saw just stunned me. In the over a decade since I had first been there, a tidal wave of lights had just swept out from both LA and San Diego and the various bedroom communities and just enveloped the mountain. A dark sky was no longer even a possibility where we were at Palomar. And this used to be the largest, most powerful telescope on Earth. Well, that summer, after that experience, I happened to be camping up in Yosemite. Yosemite National Park. Anybody been watching Ken Burns' documentary this past week? Fantastic. All right. It's camping out there, National Park, evening ranger program. And I decided, well, let's go see what it is. And it turned out it was a ranger talk about astronomy. Great, I love astronomy. Let's see what the fellow has to say. And what he said stunned me. He was a ranger from Bryce Canyon National Park out in Utah. And he gave a talk on how the National Park Service was now getting into the business of measuring and monitoring the amount of light pollution over the parks. Because as it turns out, when they start talking to their park visitors about what are those things that draw you to the national park, what are the things that you cherish the most, that are most integral to your park experience, waterfalls was up there, arches was up there, canyons, but above them all was actually stars. Camping out under the stars turned out to be a huge draw for these folks. And the Park Service began to realize, as they started keeping records, their most highly attended, the most popular programs that they were offering were astronomy talks. And the reason for that is the features that would draw you to the national parks during the day, those wide open vistas, the beautiful lack of billboards hanging from the arches, the failure of condominium developers to put condos on the tops of those buttes. Those things that kept the parks pristine during the day make the parks a natural refuge for the night sky at night. Half the parks happen after dark. 50% of the parks happen above the horizon after the sun goes down. So, I went and spent a year working with the Park Service. Well, it's been 4 or 5 years at this point. But when I had a sabbatical from my university back during the 2007-2008 academic year, I spent 12 months traveling through 12 national parks, working with park rangers, giving talks to the public. I've given talks in campgrounds, park lodges, visitor centers, spoke to rangers exclusively, to park visitors, looking at how can we take advantage of the fact that this audience that we have in the park looks up and sees something they have never seen before. It is something as alien, that Milky Way arching overhead is as alien as the glaciers, the geysers, and the granite that otherwise bring visitors to the park. So when I was out at the parks, one of the things I needed to do was actually capture images of what the sky looked like, what this pristine sky looked like, so that both visitors and park rangers, who, frankly, most park rangers go home at about 5 o'clock at night. They don't stay around. They don't see what this thing is they have overhead. And if they do, well, they live there. So they've just gotten used to that's the way it always is. In fact, that's the problem. Most folks who live in places like you, out here where you can still see the Milky Way, well, you get used to it. You take it for granted. Those of us that live where I am, if they've grown up their entire lives there, they get used to that. They take that for granted. It's only those strange few of us that go back and forth between these places that really realize what's disappearing. And so I would go out at night, the sun would go down. Here it is sitting behind Fajada Butte in Chaco Culture National Park down in northwestern New Mexico. And one of the things, if you've ever been to a national park, especially a park that maybe has a big scenic draw, big iconic draw, like maybe Delicate Arch in Arches in Utah, or the El Capitan or Half Dome in Yosemite, there are certain places where it's sunset, it's shoulder-to-shoulder photographer. Everyone is lined up there getting that one perfect picture when the sunlight hits it just right, and there's 1,000 of you trying to share this special moment. But once the sun goes down, all those people pack up and they go in. But that's when I would come out. So here I'd capture the sun, setting behind Fajada Butte. And maybe if there's a tiny crescent moon, it'll be hanging up there in the western sky. Glacier National Park. And if there is no moon, or if it's just a thin crescent and it sets, the stars begin to come out. And you begin to see this wonderful thing that most of us city dwellers have long ago forgotten really exists. This beautiful star-filled sky. So many stars that those constellations that we're all kind of familiar with, the Big Dipper and Orion and Cygnus and Sagittarius and Scorpius, those things on our planisphere wheels or our simple star charts, those things are utterly wiped away because there's now 1,000 times more stars visible than what those simple things showed. And then, if you're lucky and it's just the right time of year, you get the Milky Way. That big symbol up there in the sky, that we are part of a larger collection, a larger celestial body, that 100 billion stars. And it's that Milky Way that has become a symbol for what we have lost because so few people today can actually see it. And it's that Milky Way that is still visible in the national parks. Now, the night sky is something that's been an integral part of humanity. Well, ever since we've been humanity. At some parks like Chaco here, the big central feature of the park are Native American dwellings, many of them having celestial alignments. The stars played a very important part. They're part of our cultural heritage. And so we have been astronomers for thousands and thousands of years. But you know, even if you couldn't see the stars, even if you never saw the stars, it's still possible to experience astronomy in the national parks. For instance, Acadia National Park, up here on the Gulf of Maine. I just came back from there, as a matter of fact. Beautiful place, cloudy. But yet astronomy is staring us right in the face there. The tides. Notice the change from dark to light. That boundary there is high tide. Another example. Here's right outside the town of Bar Harbor. Low tide. There's some wonderful hiking there in the hills. Just make sure you come back to town about an hour and a half after low tide, because when the tide comes in, it becomes an island. The average change between low and high tide here in Bar Harbor in Acadia National Park is 11 feet. During certain months, certain times of the month, they can get up to 17. The tides are an astronomical phenomenon. Well, in fact, they're an astrophysical phenomenon. The reason we have tides is because of the moon. An interesting fact, we are celebrating the International Year of Astronomy this year. That's the 400th anniversary of the first person, often Galileo, credited Galileo, pointing a telescope at the sky. And in fact, one of the things that Galileo did in trying to prove the Copernican system that Earth went around the sun was look at the tides. He thought the tides were actually a proof that the Earth must move. It was water sloshing around as the Earth moved. All right. Well, the moon. The moon is responsible for the tides. And the reason the moon is responsible for the tides is, as we've all been taught in our intro physics or astronomy class, is the force of gravity between any two objects is proportional to the masses and inversely proportional to the separation, or the square of the separation, between the two. The farther away you get two things, the quicker that force of gravity drops off. Well, the Earth and Moon are not point sources. We actually have size. We have dimension. So when you're standing on the Earth, if you're on the side of the Earth closest to the Moon, you feel a stronger gravitational pull to the Moon than, say, if you were standing at the pole. And that person standing at the pole feels a stronger gravitational pull than, well, the person at the back side of the Earth. Depending upon where you are on the Earth, side close to the Moon, the center of the Earth, the side farthest away from the Moon, each of those three positions feels a different gravitational pull from the Moon. So as a result, the Earth is stretched. Now, it turns out rock is not all that fluid, but fortunately the Earth has a fluid that is more fluid, and that fluid is the water, the oceans. So, on one side, a bulge of water is pulled off the Earth. That's high tide. Where that water, say over Europe, the Moon's over Europe, bulge over there, where that water is pulled away from our shores, we experience a low tide. On the opposite side of the Earth, however, there's another bulge. That bulge comes about because over there, the Earth is essentially pulled out from underneath the ocean. And so you get a second bulge. As the Earth turns once every 24 hours underneath those two bulges, we get tides more or less 12 hours apart. Astronomy. Whenever you see a tide pool, you are seeing astronomy. Here in this tide pool, well, we have the reflection of Jupiter. Jupiter's a planet, and Jupiter's in fact a planet with its own moons. It also experiences tidal forces. So when you stand and look at any tidal pool or walk along any beach, you are experiencing forces that are at work between astronomical bodies all throughout the universe. In this case, Jupiter and its moon Io, shown here by the New Horizons spacecraft. The other photographs were all mine. I did not take this one. I do not have a telephoto lens quite as good as this. All right. Now, you may notice something about this picture of Io. Io, by the way, is the yellowish moon there. It's about the same size as our own moon. Jupiter, however, is quite a bit larger than the Earth, about 300 times the mass of the Earth. So the gravitational forces between those two objects is going to be quite different. You may notice that on top of that yellowish moon Io, there is this little blue top knot thing. Here's a close-up from the Galileo spacecraft. What you are seeing are the volcanoes of Io. Every single black dot on this moon is a volcano. The volcano, the heat for that volcanism, comes about from tides. In just the same way that our moon tries to stretch out the Earth and raise these two bulges, the gravitational pull from Jupiter does the same thing to Io, except there the rock really does stretch. Now, Io has an elliptical orbit around Jupiter. That means sometimes it's close, sometimes it's far away. That elliptical orbit is kept so by interactions, resonances with the other large moons of Jupiter. In fact, once again, we are celebrating the 400th anniversary of Galileo. This upcoming January will be the 400th anniversary of Galileo first looking at Jupiter and seeing these four large moons, the Galilean satellites. Well, because of those resonances between those Galilean satellites, the inner three, The distance that Io is from Jupiter is continually changing over its 1.7-day period. So the degree to which Jupiter's tidal forces stretch it are constantly changing. And this poor moon is stretched and compressed, stretched and compressed. Inside it, the rock rubs back and forth against one another, creating friction. Friction creates heat, and as that heat escapes outward through the moon, you get volcanoes. The yellow, the colors that you see here, are sulfur compounds from that volcanism. Here's a close-up of Patera. Looking down on this, what you are probably seeing is a molten lava lake, the dark blackish material. You have sulfur, the reds and greens are different sulfur compounds. To give you a sense of scale, this thing is about 50 kilometers in diameter. If anybody's ever been to Yellowstone National Park, anybody here been to Yellowstone? You're looking at something about the size of the national park. The largest volcano in the solar system, however, is not Patera, but Loki Patera, 250 kilometers in diameter, 5 times larger. This is the largest volcano in the solar system. Well, okay, Olympus Mons is a larger volcano, but this one is active. This one has been erupting continuously. Now, when most of us think of volcanism, we think of something like this from Hawaii Volcanoes National Park. Something molten, liquid, red, glowing lava pouring down a hillside. Maybe it's a nice steep cone. This river of molten lava rock flows into the ocean. You get steam. This is what we think of as volcanism. However, this is a kind of volcanism that very few folks actually ever get a chance to see. Much more common are those of you who raised your hands when you said you'd been to Yellowstone. This is volcanism. Geysers. Underneath Yellowstone National Park, there is a plume of molten rock that has welled up. That molten rock, as it sloshes around inside this lava chamber, cracks, fissures. Little tremors caused cracks to develop, and these cracks, as they funnel rainwater, or in this case, snowmelt, through this system of channels, the lava, the magma in there, heats the water up, and you get a hot water plumbing system that builds up pressure, builds up steam, until at certain places, the pressure's released. The water shoots out, and you have a geyser. If you've ever been to Yellowstone, you have been on top of a volcano. You have experienced it firsthand. I was out at Yellowstone National Park in February, partly because one of the things that's amazing about the Earth, one of the things that's very special about it, is we can be someplace where we can experience water as a liquid, a solid, and a gas, all within a foot of one another. Now, the most famous geyser of all is Old Faithful. And one of the things I wanted to experience as I was out here is the thought of a geyser erupting by starlight. And so I went at 4 a.m., because it turned out that in February, the only time you ever got stars shining above you was at 4 a.m. And so in part of the work that I was doing with the Park Service, I was measuring how dark it was above various parks as I was traveling along. So I had my little light meter that I would go out to. So I thought, well, if I'm going to get any measurements, I better be out there at 4 a.m. So I got it, set my alarm off, got my snowshoes on, got my parka on, went snowshoeing out, dodged the bison, avoided the elk, got out there, thought, well, let me get a photograph of the geyser as it erupts. And as it turns out, just as I got there, I heard it start. So I plopped the tripod down, put the camera on, snapped a picture, and this was it. And interestingly enough, the bright star, the bright yellowish star that you see up there in the plume is not actually a star at all. It's the planet Saturn. And that's important, because Saturn's, well, it's a planet, ringed planet, beautiful planet, once again, not my photo, Cassini spacecraft. But like Jupiter, Saturn also has moons. Here's one of those, Enceladus. Enceladus is a tiny moon. It's quite small. It's about the size of Texas, say. I'm from Alaska, so I like to point out how small Texas is. All right. Enceladus is the brightest moon in the solar system. It is the same albedo, the same brightness as new fallen snow. Pretty interesting. Unlike our moon, it only has a few craters. You may have noticed the picture that you saw of Io earlier had no craters at all on it, no impact craters. The reason is because it has those volcanoes. The surface is recovered in new eruptive compounds to a depth of about a centimeter each year. When you look at Enceladus, again, very few craters. Something is happening to the surface of Enceladus that wipes out those old impact scars. Well, when the Cassini spacecraft flew by, in these photographs, one of the things it captured that had never been seen before, and this is about 2005, is at the south pole of Enceladus, you have these blue cracks. They're called tiger stripes. Interesting. What are they? Didn't know. But as the Cassini spacecraft flew by, it turned around, and it took a picture of the night side of Enceladus, streaming off the south pole, exactly where those tiger stripes, those blue cracks are located, were geysers, streamers of water erupting off the south pole of Enceladus. The newspapers covered this, made the New York Times. How often does astronomy make the cover of the New York Times? And they called it Cold Faithful, partly because Old Faithful was probably the only geyser anybody knew the name of. All right. But it turns out they may have been more correct than they thought. The reason why geysers are erupting off of this frigid ice moon. Now think about it. Saturn is out at about 10 astronomical units away from the sun. So about 9 times farther away from the Earth than from the sun than the Earth is. Very cold, 100 times colder out there than it is here. Enceladus, that new fallen snow, is mostly ice, water ice around a rocky interior. Just like Io, it experiences tidal forces that stretch it, because it also has an elliptical orbit. So it's stretched and compressed, stretched and compressed. That internal heat melts some of that surrounding water ice, giving you subterranean pockets of liquid water. And as Enceladus would go around Saturn, when it made a close approach to Saturn, the tidal forces would be oriented in just such a way that those cracks would open up. The geysers would shoot off. And Enceladus would continue on. And as it got a little farther away, the orientation would change slightly, and the tidal forces would close those cracks back up, and the geysers would turn off. Once around, back to a closest approach, tidal forces, cracks open, geysers shoot off. These may be very well periodic geysers, just like Old Faithful. New York Times may have been even more accurate than it thought it was. To give you a sense of scale, imagine if you could scale Enceladus up to about the same size as the Earth. These geysers would stretch 6,000 kilometers out into space. All right, so no need to crowd around the boardwalk there. Everybody would get a good view. All right. So these are examples of ways in which going to the national parks, not just what's overhead, but what's on the ground, informs you about astronomy, planetary science, our place in the universe. A little closer to home, a little closer to here, Red Rock Country in Utah, if you've ever been out there. The red that you see in the landscape, it's iron oxide. Iron in the rock that's reacted with oxygen, rust. Red Rock Country is red because of rust. Well, that's the exact same reason Mars is red. The red of Utah, the red planet, red for the same reasons. There's a photograph taken by the Opportunity, one of the rovers on Mars that's, by the way, still trundling around, 5 years in. Give you a sense of scale here. That grinding mark, that circular grinding mark, is only about, I think, a couple inches in diameter. One of the things Opportunity found as it was trundling about on the plains of Meridian were blueberries. These little spheres, little hard spheres. Turns out they're made out of iron concretions. They're iron hematite, gray hematite iron concretions. Interesting. Well, if you've ever been to parts of Utah, in this case the Escalante Grand Staircase area, there are also little iron concretions, gray hematite. The reason why you have these in Utah is because of groundwater percolating through that sandstone, that red, beautiful red sandstone with the iron oxide. That water picks up that iron oxide, bleaches it away from the rocks, and transports it through this plumbing system, which is this very porous sandstone. In fact, it's the Navajo sandstone. It's fossilized ancient sand dunes. So it's not incredibly dense as sandstone goes. So this water that pours, that groundwater that pours through, bleaches the rock of that red mineral, carries it until it encounters water of other chemical, carrying other chemicals, and it precipitates out. And you get these little concretions, these building pearls of iron oxide. You only find these in the Navajo sandstone here on Earth, and that indicates that water has been seeping through the rocks. Its presence on Mars indicates that something very similar has probably happened there. Water has been flowing on Mars, if not now, at least at some point in the past. So when you look about you, here in the desert Southwest, when you're flying from, in my case, Los Angeles to Denver, and you look down on Monument Valley, what you are seeing is a landscape that, while quite different from what you would find on Mars, has aspects of it that inform you very much on what Mars is like, could be like, or once was like. There are similarities there that tell us about the place. Now, getting out and exploring, seeing the sky, seeing the landscape is something that we just do not do very much anymore. The Milky Way, as I said before, has become a rarity to be seen. When you look at the Milky Way, however, you learn about our galaxy, our place in the galaxy, the fact that one part of the Milky Way is brighter than another part. Here we are down in Arches. But the reason why very few folks even see that anymore is because of this glow that we see here over the landscape from Glacier National Park. It's the town of Browning outside the park in western Montana. This glow is seen here from space. This is taken from the Rosetta spacecraft that was on its way to a comet that performed a flyby of the Earth, looked down, and captured this view of the Earth at night. And what you see here is from Europe over across to Asia. In fact, let's see if this works. There's the Nile in Egypt. Here is, there's the Indian Peninsula. London is up there, I believe. And then over here, I think that's Japan. But you're seeing the hemisphere at night. Those lights that you see, well, here's a better view of the entire world. It's a mosaic, the USA, different continents. All right. Every single light that you see, that's us. And because these were taken by spacecraft, every single light that you see here was a light that was shining upwards. Light that was illuminating a spacecraft. But yet it's light that we generate, that we pay for. Every kilowatt shining up, illuminating this satellite is light that we paid for. Here's another map of the U.S. This, in fact, of the western U.S. We've taken that information and color-coded it. So dark is black, all the way up through greens, yellows, reds, and whites. The red regions here are national parks, national monuments, recreation areas. The blues are freeways, interstates. All right. And one of the things you notice is, yes, there are some regions of blackness, but there are many, many more regions of brightness. Here's the eastern U.S. Notice how different the eastern half of the country is from the western half of the country. Yet, I want to say something. When you take a look, let's go back here. Take a look at the world. Notice that dichotomy in the United States, the bright eastern half, the dark western half. But now look at other developed parts of the country, in particular Europe. There is no place in Europe that is as dark as the darkest places here in the United States out west. If you want to see something as dark as central Utah or southeastern Oregon or central Nevada. You have to go into the mountains of Norway or out into the middle of the Mediterranean. Let's in fact blow up Nebraska here. All right. So, all right, let's see. I just flew in this afternoon, so let me see if I can guess to where I actually am. Oh, rats, I'm going to get... Are we there? Oh, good. All right. I figured I had a 50-50 shot. Okay. But notice this giant black region that you have right there. Where is that, by the way? Sand Hill. Okay. You have the largest dark region east of the Rocky Mountains. All right. But notice also, though, how far the light dome from each of these cities extends. So for instance, what town that is? Okay. Notice how far out its dome really goes. All right. Our towns, our communities, the lights of our civilization expand farther than the light fixtures themselves. We have a very great impact on the countryside around us. All right. So the national parks have been investigating this because they are tasked by Congress to preserve these natural wonders for the enjoyment of the people. But if part of that natural resource is not just what's on the ground, but what's overhead, they need to find a way of seeing what is the resource they actually have and how are they, within the park, impacting it, but also the communities around outside the park. Here's a photograph of the night sky taken from Death Valley National Park. The band going through the middle is the Milky Way. So once again, blacks are the darkest, all the way up through the spectrum, down to white here. If you can see these numbers on the left-hand side from where you're sitting, you've got better eyes than I do. It's in units of magnitudes per square arc second. The Milky Way goes through the middle. Notice the other bright features. This down here along the horizon. That's my house, Los Angeles. Feel bad about that. Over here towards the east, any guesses what that might be? Las Vegas. Very good. Let's see, in fact, yeah, so Las Vegas, all the casinos out there. One of the most remote sites in all of North America, and yet my house down in Los Angeles and the casinos in Las Vegas have an impact on what can be seen there. A bit closer to my home, this is Joshua Tree. It's about an hour-and-a-half drive from where I am. And now you see the entire western horizon. This is Los Angeles. Down here is Palm Springs. Up here is 29 Palms. In fact, the sky is so bright that even though you can still faintly make out the Milky Way, the sky backlights the Joshua trees. The sky is brighter than the landscape. This is Arches National Park in Utah. Here we have the Milky Way coming in, and this right here is the town of Moab. Moab is so bright, even though the population's only about 10,000, it still blots out the Milky Way, and it reflects, or it shines onto the rocks within the park. There is now no point in this national park, in this area, where you have natural darkness anymore. Any plant, any animal, the ecosystem of that part of the park now exists at a permanent full moon. Now, why should we care about that? The reason we should care, well, the loss of natural light affects the biosphere. There are plants and animals, entire ecosystems that have developed to take advantage of night. After all, back before human beings invented the light bulb, night happened for roughly half of every day. In many places, it no longer does. There are many nocturnal species that have evolved to take advantage of this that no longer can. One story involves raptors, these birds that prey on little rodents and scurry things at night. All right, folks in one area wanted to preserve the habitat for these objects, so they didn't build, so you had trees, you still had the brush. You had everything that you needed for these birds, except for whatever reasons the raptors moved on. They could not feed there. They could not survive. Well, why not? Turns out at night when these things would normally come swooping down on some poor innocent little mouse, silent death from above, the sky was now so bright that they would cast a shadow onto the ground, alerting their food that they were there, and the mice would scurry away. Everything else about their habitat appeared to be there, except the night, and the night was enough to destroy it. All right, maybe you don't care about animals. Happens, all right? Why else should we care about this wasted light that we're shining up into the atmosphere? Well, it's wasted electricity. It's not doing any good. It's shining up there, illuminating the undersides of spacecraft, but you still pay for it. And we still generate that electricity that's shining up on spacecraft, so we're still burning that coal, using those natural resources, and all of that goes to waste. Well, how much waste? Here's a typical decorative light fixture in many a college town. This is actually from my town. 50% of that light shines straight up, above the horizon. I don't know about you guys here on campus, but I know that on my campus, bat people swooping down to steal the students away is not a huge problem. So the light shining upwards is not really that necessary from a safety standpoint. 10% of the light shines straight into your eyes, horizontally. That's glare. That's bad. The one time in all my travels through the national parks I actually hit an elk was when I had a truck coming straight at me with its brights on. That glare prevented me from seeing what was directly in front of me. Only 40% of the light put out by this light fixture actually does what we want lights to do, to make us safe. Allow us to see the sidewalks, to see pedestrians, to see places that we don't want to drive, to see the bad people. That's the productive light, and only 40% of this light is productive. That means only 40% of the electricity used for this light is productive, which means only 40% of the resources used for the electricity for this light is productive. All right. Well, what happens to this light? What I've got here is a decorative light fixture, just like what I showed before. Half of that light, or 40% of that light, shines down. That's the useful stuff. The rest of that light shines upwards, and it bounces around all that stuff that's in our atmosphere. As an astronomer, I really wish we didn't have one. All right? But it does have its uses, I will admit. But it's bad. And the reason it's bad is, let's see, these little double things, those are oxygen molecules. These blue things, that's water vapor. The brown things, I'm from Los Angeles, so that's smog. Let's say it's dust, whatever. The light that goes up scatters around all that stuff, and eventually, much of it bounces back to us. And so it appears that the sky itself is glowing. All right. Well, up here you have, yay, distant little star. Light's been traveling for 1 million years to get to us, and that last femtosecond, as it travels through our atmosphere, it is joined and overwhelmed by all this much closer, much brighter light. As that glow from the sky gets slowly brighter and brighter, it prevents us from seeing those faint stars. But if you simply put a shield on top of your light fixture so that no more light travels upwards, our poor little star comes back to us. The stars shine all day long with exactly the same brightness. The only reason we can't see them during the day is because the background from our sun is so much brighter. At night, when that background is artificial from our own streetlights, we cannot see them. Take that background away, and the stars come back. Now, maybe, if you're worried about electricity or resources, that light that used to shine upwards, you could paint the underside of your lampshade white or make it reflective, and all that light that used to go up comes back down, and you get even more light on the ground where you might want it. And if you don't need all that extra light on the ground, put in a lower wattage light bulb, and you save electricity. You save light, you save electricity, you save money. You save the sky. It's a win-win, win-win situation. Everybody wins. So, on the left, bad light. glare light, light that shines upwards, bad, bad, bad. On the right, you get the light shining down exactly where you want it. Maybe it's over your front door, so you can put the key in the lock. Good light. In the national parks, many parks have begun retrofitting the lights they have in the park in order to be more light pollution friendly. And because the national parks are historic places, they don't want to look like Buck Rogers by having all these crazy sort of antiseptic looking light fixtures. So they have these oldie-timey light fixtures that they have. Some of them they've actually constructed themselves, but others are available out there. Glacier National Park in Yellowstone. In case you don't notice it here on the Yellowstone one, the light fixture is actually up here in the top, and the glass panes have been removed. So the light simply shines down. The only reason I even noticed it is, well, I was looking for this sort of thing. If you're interested in light pollution and how to prevent it, one place to go in order to find out information is the International Dark Sky Association website, darksky.org. They actually have links to manufacturers that produce these light pollution friendly fixtures. Because unfortunately, you go to some place like Home Depot or Lowe's right now, and I don't know if you've ever scrolled through their outdoor lighting fixtures. I have. Of the 300 varieties that Lowe's carried, there were 4 that were light pollution friendly. Right. But you can find manufacturers through the Dark Sky Association. Thanks to the Dark Sky Association, Natural Bridges National Monument back in the summer of 2007 was declared the first international dark sky park, partly because of this image right here. This shows their entire sky. It was taken in summer. And one of the things that you may notice is that the brightest thing in here is not something along the horizon, but it's this. That's the center of our galaxy. Standing there in Natural Bridges, looking around, you cannot see a single light dome from any city, any town, any house, anywhere. The brightest thing in the sky is the galaxy itself. And in fact, here's a photograph taken in Natural Bridges. The center of our galaxy rising through the bridge itself. I had never seen a place as dark as that by the time I was there. All right, now why is that interesting? Well, as I mentioned earlier, when you see the Milky Way, when you see that bright, amazing band in the summertime, and that sort of faint, tenuous band in the wintertime, you are getting a sense of where we are in our galaxy, the Milky Way. Here's an artist's conception of the Milky Way. A flat pancake, a pinwheel, of about 100 billion stars. Our sun is not at the center. If we were at the center, then looking at that band across the sky, you would probably expect it to be equally bright everywhere you looked. In fact, the very fact that it is a band tells you that our galaxy is flat. If we lived in a giant ball of stars, a big elliptical galaxy, for instance, then you could look out and there'd be pretty much equal amounts of brightness everywhere, especially if you were at the center. If you were maybe off-center of an elliptical galaxy, there'd be a huge ball of stars maybe in the summertime and almost nothing in the wintertime. But rather we see the rest of our galaxy as a band. And that's because we live inside of this flat pancake. Because half of that pancake is brighter than the other half of that pancake, that means we're off-center. In the summer, let's see if I got this right. Oh, well, here's an example of another galaxy. Once again, not mine. Hubble Space Telescope. And here's an example of another galaxy, once again, but showing it edge on. Showing just how thin a galaxy truly is. And notice, right along the middle of that thin disk of that spiral galaxy is this dark, splotchy stuff. Here's the Milky Way from Rocky Mountain National Park, the summer Milky Way. And again, notice, right through that middle of that bright part is this dark, splotchy stuff. What you are seeing are clouds of dark interstellar dust blotting out the light of the more distant stars behind them. In essence, they are being backlit by the rest of our galaxy. So here's that summer Milky Way, that bright heart of our galaxy. This is Sagittarius, so there is towards the center of the galaxy. You wait 6 months, And you get a less impressive part of our galaxy. That's the part directly away from the center. Not quite as impressive. So here's that galaxy, that artist's conception again. So in the summertime, when you see Sagittarius, you're staring straight towards the center, and Antares a little bit off. When you see the summer triangle, Deneb, Vega, and Altair, you're looking off in this direction. In fact, the reason why the part of the Milky Way in Cygnus, the Northern Cross, the heart of that summer triangle, looks as bright as it does is because we are staring almost straight down a spiral arm. When wintertime rolls around and you see that faint nebulous winter Milky Way, you're looking almost straight away from the center. In fact, directly opposite, away from the center of our galaxy, is the Milky Way off in the direction of Taurus, the bull, sort of where the horns of Taurus are. And as Orion comes up, again, we're looking away. There is a place here in North America where if you stand there at the right time of night, the right time of year, the part of the Milky Way, well, in fact, if you were standing at the North Pole of the Earth, and you look straight above you, you'd see Polaris, the North Star, that point off in interstellar space directly above the North Pole of the Earth. There is a point off in intergalactic space, which is directly above the North Galactic Pole of the Milky Way. It's called the North Galactic Pole. There is a place here in North America that you can stand where that North Galactic Pole will pass overhead, almost right through the zenith. That place is in Big Bend National Park. If you go there, at that time the North Galactic Pole goes straight overhead, you will be there at a time that the entire band of the Milky Way will wrap itself around your horizon. And for that moment that you are standing there, you're upright in the galaxy. You are standing perfectly perpendicular to the plane of our galaxy. And that time happens in March, about 2 in the morning, the very first week of March, which is when I happened to be there. As I stood there, I saw the North Galactic Pole. It's right off of the open cluster of Coma Berenices. I happened to see that go right overhead. I looked down off towards the southeast, and I began to see the wispy glow of the Milky Way in Sagittarius rising above the horizon. In fact, I saw the entire summer Milky Way rising in unison above the eastern horizon. And as beautiful as a sunrise is, as I stood there, I knew that I was seeing a million sunrises. And it was utterly spectacular. And I could only see it because in Big Bend National Park, you are nowhere near any kind of city. You are absolutely, utterly isolated. In fact, this is something I hadn't quite realized. Because of where the Rio Grande dips down, that's where Big Bend is located out in West Texas. Because of the dip that the Rio Grande makes, as you stand there in Big Bend National Park, any airplane that would fly overhead would have to go in and out of U.S. and Mexican airspace. There were no planes overhead at all. No lights on the horizon, no towns nearby, no planes overhead. There was absolutely nothing there besides a single glow of a single satellite passing overhead to tell me that the electric light had even been invented. And it was the darkest place I ever saw. Well, back in the 1930s, the national parks had a program to get people, an initiative during, well, the last Great Depression, to go out and see the wonders of America. Go out and see, spend their money, and see what a beautiful place America is. And we're doing that again, to get people to go out and see America, but see not just the wonders below the horizon, but now to see the wonders above it. And as time goes on, these will be the only places you can go, and so they are very precious and must be protected. So I want to thank the Park Service. I want to thank you folks for being here, and I want to thank you for being interested in this type of material, because only when those people are interested will we ever protect these things. And by the way, I will just throw out, as I was working with the National Park Service, we wrote a book describing all this material for the average park visitor of how they could experience astronomy in the parks. And that should come out in spring of 2010, so keep an eye on it for it. So thank you very much.